Before we solve the absolute value of x less than or equal to 6, we want to think a little bit about what that statement exactly is saying. So if we sketch this out on a number line, the absolute value of x less than 6 means we want all values for x which are less than 6 units away from 0. So we can mark out 6 units in the positive direction or to the right, which would mean our solution should include all values between 0 and 6. But we also want to think about that idea that absolute value doesn't worry about direction. So we also need to think about values that are 6 units away in the opposite direction. So what we would see there would be -6. But again, -6, even though it's in the opposite direction, is still just 6 units away. So if we want all numbers that are less than 6 units away from 0, we want all values between -6 and 6. And then we just need to think about what kind of indicator we need at 6 and -6. Since we have a strict inequality, in this case we would want open circles, again indicating that 6 and -6 aren't included as part of the solution, but all values in between are included. So this would be the same thing if we were to express this as an inequality statement, as -6 is less than x is less than +6. So we have another one of these bounded inequality statements where all of our solutions are contained between these two numbers. And then we could translate that into interval notation as -6 to 6 with rounded parentheses on both ends, since we have open circles on both ends of our number line and strict inequalities for both of our inequality statements. So this solution, -6 is less than x is less than 6, is also going to give us a structure for how we can solve some of these additional examples. For instance, in example 2, we have the absolute value of 5x is less than or equal to 10. Taking the idea of this previous inequality statement, we can set up two different statements. Since we already have that absolute value portion isolated, we could set up the statement 5x is less than or equal to 10 and would also be less than or equal to -10. So again, following that pattern up above, we take whatever value we originally had on the right hand side of that inequality, drop those absolute value bars, and put that opposite value on the left hand side, and then our value for x becomes bounded between those two numbers. So what we have in this case is the absolute value of 5x, now bounded between -10 and 10, and we can look at solving that compound inequality. In order to do that, what we'll do is divide all pieces of that inequality by 5. So this will give us -2 is less than or equal to x, which is less than or equal to 2. Now that we have that compound inequality solved for 2, we can translate that into interval notation, which would be -2, 2, with closed brackets on either end, since we have that or equal to statement. And we can express this in number line form by putting filled in circles at -2 and +2 and shading that region in between. We'll apply our same approach when we look at solving, apply that same approach when we look at solving example 3, but we will have one additional step here, that we first need to get that absolute value portion isolated by itself. So in order to do that, we'll start off by subtracting 1 from both sides to get the absolute value of x minus 4 is less than 4. Once we have that set up, Then we can rewrite this by dropping those absolute value bars, and then taking that expression that was in our absolute value bars set as less than 4, and then also greater than -4. So again, creating that bounded inequality statement, and then solving by applying the same operations to all three pieces at the same time. In this case, what we'll be doing is adding 4, which will give us 0 is less than or equal to x, is less than or equal to 8, which we can translate into interval notation as 0, 8, with rounded parentheses on both ends, since we have those strict inequalities. And then representing that in number line form, we can use open circles at 0 and 8 and shade that region in between. In example 4, we can start off by adding 11 to the other side of this inequality statement, which will give us less than or equal to +7. Once we have our absolute value statement isolated, we can set up that compound inequality where that absolute value expression is bounded between +7 and -7. We drop the absolute value bars and then solve that compound inequality. In this case, we'll subtract 1 from both sides, which will give us -8 is less than or equal to -3x, which is less than or equal to 6. And then in our last step, we'll divide by -3. But what we need to keep in mind is that if we multiply or divide inequalities by a negative value, the direction of those inequality statements flips. So this would become +8/3 greater than or equal to x greater than or equal to -2. Representing this in interval notation, we still want to keep in mind we want to consider the smallest value and then the largest value. So in this case, the direction of our inequality has changed. So -2 is our smallest value, all the way up to +8/3, with closed brackets or square brackets on both ends, since we have those or equal to statements attached to our inequalities. In this case, 8/3 would be just a little bit less than 3. So we can use filled in circles to represent either end of our number line solution and shade that region in between. In example 5, we have the absolute value of 3x plus 5 less than -4. But what we know is that the absolute value of 3x plus 5 has to be greater than or equal to 0, because the absolute value of anything always has to be a non-negative result. So the fact that we have this absolute value statement set to be less than some negative value, or even just strictly less than 0, means that there is no solution, or that the solution is the empty set. This would be another case where that's just an idea that we have to catch on to. We could apply the same approaches that we used previously. We would generate a couple of solutions, but if we tried to substitute those solutions back into this original inequality statement, we would find that neither of them would make this statement true. So you can either spot that ahead of time by thinking sort of intuitively about what absolute values are and what values are restricted, or always just checking your solutions, and if your solutions don't work, that either means your solutions are wrong or possibly that you made a small mistake along the way.